Hello, ARRL members and QST readers worldwide. I'm Dave Kassler, KE0OG, and I am the author of the Ask Dave column in QST. In September's issue, we talked about the concept of a diode limiter, and I want to show how that works here. I've managed to scrounge a couple diodes off an old project board I haven't used in about 40 years, and we're going to show them in this image right here. Two diodes back to back. So let me draw this on the whiteboard. So let's suppose you have a line coming in here and a line coming in here, and we'll just assume that this one is grounded, okay? So this one is the hot. What we're going to do is put in a diode going this way. Now you would think that that would short the circuit between the two. Let's get the rest of that diode drawn in. But there's a forward 0.7 volts. Forward is 0.7 volts. So if we look at this on the oscilloscope, I've got the signal generator here set up for 1 kilohertz at 7 volts peak to peak. And we look over here on the oscilloscope and we see 7 volts peak to peak. It's 2 volts per division. So there's 2, 4, 6, 8, and it's down a little bit from that. So we're going to call that 7 volts peak to peak. Now, I have all these diodes here. I have this diode, and watch what happens. I'm going to connect this up. These are the two diodes. They're very tiny. And I'm going to connect this right here, and you'll notice that there's clipping. See, the bottom part is clipped off because here we see the T is the trigger. That's 0 volts. We're down here a little bit below that where we have minus 0.7 volts. Okay, so that gets through, and then of course the swing going the other way, I can reverse that with another diode that I have in reverse, and we get the opposite effect. But note that we get a little bit of flow. If this is 2 volts per division, this is somewhat less than 1 volt. It's about 0.7 volts, okay? So this is when you have one of these, it will cause clipping like that. Now let's suppose we put another one in here, like this. Again, it's going to have a 0.7. So what this will do is let any signal go through that's less than 0.7 volts peak, okay? And we'll clip anything else that's higher than that and hold it to the 0.7 volts peak for here and for here. Okay, let's connect both of these at the same time. Okay, what do we get? What we see here is a signal that's 7 volts peak to peak, but it only comes up to 0.7 volts positive, 0.7 volts negative. Okay, I don't have this exactly centered right there. Okay, so this can act as a limiter. Now let's go over to the signal generator here and lower this voltage. Okay, now look at that. We're at 1 volt peak to peak, and we can go up to 1.4 volts bottom to top, and we're letting that sine wave through without any clipping on the top of it. This is called a diode limiter because you'll get the 0.7 volts here, 0.7 volts here, which will be 1.4 peak to peak here and here, okay? And this is a very common thing that we do to prevent a large signal from coming in and damaging the front end, okay? And this really is a sine wave. If we magnify it here, we see that it's a sine wave, okay? But now, if we do this, raise the voltage, we see peaking already. That's 2 volts peak to peak. Now what we've seen here is how to use a diode limiter. This is a circuit that's quite common You'll see it in schematics and go, whoa, this should be a dead short, but it's not, because of the 0.7 volt forward bias on both diodes. It will allow a signal up to 1.4 volts peak to peak to go through. This is a great thing to have like on the input or somewhere close to the input of a receiver to keep a really loud signal from causing damage to downstream components. And so I've demonstrated for you the diode limiter. Note that I also have a YouTube channel called Ask Dave, where I answer questions from hams, and you can find it at the address shown below. And until we next meet, 73.